starting here with array allocation with pointers, what I was hoping to do was kind of kill a couple of birds with one stone here, which is a gruesome metaphor, I suppose. So for this one, what we're going to do is dynamically allocate an array of a size that the user determines. So as opposed to most of the other examples you saw in the text, where array, whatever the array's name was going to be of a size that you had already declared, here we are going to allow the user, in that case it's going to be me, to say the size of the array. So I'm going to say 5 anyway. And then they're going, we are going to go through and populate the array with values. So just to prove that this can keep working, if I say 25, we're going to run that, and it's going to go 0 through 24, because remember, again, array operations start with 0. So if we step through the code here, first and foremost, we're going to notice that here in our function prototype, here is the idea of our pointer. So int star array allocator, and again, we are going to pass to it an int, and that int is actually the number here that I, the user, input. So that's the number of elements. Here I have my null pointer, so int pointer, and remember again that there the asterisk indicates to C++ that this is in fact a pointer, and null pointer is essentially the same as initializing this value to 0. Instead of 0, it's saying it doesn't point anywhere instead of 0. And then we have an int that we can use to iterate through our arrays. So here is the wrinkle for this chapter, essentially. So we're saying that pointer, which remember is a pointer to an integer, in this case it's a pointer to an integer array, equals array allocator number of elements. So we are going to create, by calling array allocator, we are going to create an array of size however many num elements is. We are going to populate that array, and just take notice of the idea of scope here. You'll notice that I do not have an array for those integers declared here inside of main. For that, we are relying right here on new. Remember, the idea of a new keyword with an array allows this to still be referenced after array allocator goes out of scope. So this line only works because here on line 43 we have the new array here. Otherwise it goes away when it's destroyed really once we go out of the scope here for array allocator. So what we end up doing is we're saying pointer equals our new array. So right there we're creating our array. Here with our little for loop, we are simply filling values into that array. And we are using traditional array notation here. So one of the things to keep in mind, one of the things to compare this to our other 3 code samples for the week is, instead of pointer sub I, so that is, the subscript of our array here, we could also use the pointer value instead. But this turns out rather to work pretty good because we have the counter here for us, and I think it's a good example to start with because this is the notation that you are accustomed to seeing, and it's also the notation that you're accustomed to seeing here with pointer sub I instead of again using the reference here, which we will do in the other 3 examples. Now I wanted to include this here because it's the other it's the other side of the coin. It's the other new wrinkle that we've added here. When we have a new, we can also have delete. So what we're saying is, before this main, or really this is main, but before this function terminates, we are reclaiming, or we are marking for C++ to reclaim, the amount of space allocated for pointer, which points back to this array, so that whatever the space is can be reused by other methods when they're being called. So those are really the big wrinkles here. We have our null pointer, and that's like initializing a pointer to 0. We have our pointer. The way we would reference that for C++ here is with the asterisk. Remember, this is the third way that we have seen the asterisk been used. And C++ will not screw this up, but you might. And we have here the new keyword, which helps assure that whatever it is that we are creating, in this case it's the whatever is an integer array, that we are creating in the use of this particular function is not going to be destroyed when we go out of scope for its array allocator. So I know that covers a lot of ground, but honestly, I've been pretty pleased with how you guys have been moving through the material. So I'm going to start condensing these a little bit so we take bigger bites instead of smaller ones.